the area under?
So let's open the book.
It was number 14, I think, on pages. I can find it. Hold on.
Was it here?
Yeah, I think it was around.
Okay, so we do have the limits of integration. So when x equals 1, I'm sorry, negative 1, from x equals negative 1 till x equals 4. So we have the area is the integral from negative 1 to 4. From above is x plus 28 minus the below, which is x to the 4th plus 8x to the 3rd minus 18x squared dx. Okay, is this okay so far? Okay, so there is nothing we can combine like terms here. So we can just go ahead and write x squared over 2 plus 28x minus x to the 5th over 5 plus 8x to the 4th over 4 minus 18x to the 3rd over 3. And this is from negative 1 to 4. Okay, so I'm plugging in 4. 16 divided by 2 is 8 plus 112, I think. Yes. Minus 4 to the 5th over 5. And plus 2 times 4 to the 4th. Minus 6 times 4 to the 3rd. Minus. When I plug in negative 1, I get 1/2. I get negative 28 plus 1/5 plus 2 and plus 6. Okay, so I'm gonna use the calculator right here a little bit. So let's see. Okay, so 112 plus 8, so that's already 120. And then minus 4 to the 5th divided by 5. And then plus 2 times 4 to the 4th minus 6 times 4 to the 3rd, which is 64, minus 0.5 plus 28 minus 1/5. I really wanted to write 0.2, but that's okay, and minus 8. So I got 62.5. Now, assuming I didn't make a mistake, but I don't want to assume anything, from negative 1 to 4, it's very easy with the arithmetic to get something wrong. So x plus 28 and minus x to the 4th. What was the difficult part here in this problem? Was something wrong with it, or?
I think I just accidentally did it backwards when I was doing it, because I think I did, instead of doing 4 minus, like plugging in 4 and then minus plugging in 1, negative 1, I think I did it backwards.
No, it's always the top minus the bottom.
Yeah, I think that's just the one
Okay,
place I
so
got.
here I got lucky with all these numbers. So it's indeed 62.5. Good. Very good. Anything else? Other questions? Anything? Is there anything else we need to look at? Anybody? Anything else? Any questions? Anybody? Shauna, I thought you had something, or maybe I misunderstood, maybe you don't. I say it again.
I'm okay right now.
You're okay?
Although I did do that problem wrong. I guess I flipped. Yeah. I guess I was supposed to flip it. I did not.
Just remember, you always have examples done in class. I will not select, that's why I don't even select the problem before class. So the best thing to do is to follow the examples from that we cover in class, and then you will have no difficulties. If you don't, then you make it more difficult on yourself. Okay, is there anything else we need to look at? Anything else? Okay, so I'd like to look at a couple of problems because we have not looked at something like this. Meaning, what is all this here? It's what you see here, but no preparation. Meaning, we have to graph, we have to shade in the area enclosed, we have to find the points of intersection, and then we have to find the integral which represents the shaded area. So there is no help here. From 11 through 14, we got it all. Everything was laid out for us with no effort on our side. They graphed, they found the points of intersection, they shaded in the area, and they gave us all the information. But now we have nothing. We have to start from scratch. So let's start with number 17. So in 17, we have y equals x plus 2, and we have y equals x squared. These are very simple functions. I just intentionally started with something very simple. Okay, so I know how to graph x squared. Very simple. It's a quadratic function, the simplest possible quadratic function with a vertex at the origin. So this is something that we study in all algebra classes. So this is y equals x squared. Now I don't want to graph the other one yet before I find the points of intersection. See, y, meaning, let's see what happens when they are the same, when I set them equal to each other. Y is the same with y, meaning x plus 2 equals x squared. So when I solve this quadratic equation, remember we have to have everything on one side and 0 on the other. So x squared minus x minus 2 equals 0. Now, if you say, I don't remember how to factor, there is no time for us to learn factoring again, use the calculator with the apps and find the solutions. But this is x minus 2 and x plus 1. So x equals 2, x equals 2, and x equals negative 1. So when x equals negative 1 and when x equals 2, these two lines have to, these two graphs, the line and the quadratic, have to intersect. So somewhere here and somewhere here. So when I graph the line, which is y equals x plus 2, that line has to pass through these points. How do I graph it, first of all? We practiced this at the beginning of the class. We know how to graph a straight line, meaning we have to find the x and y intercepts. So for y equals x plus 2, when x is 0, y is 2. When y is 0, x is negative 2. So the 2 points are 0, 2, and negative 2, 0. So I go back to my graph, and I plot negative 2, 0, and 0, 2. And then now I know how to graph. And this is y equals x plus 2. Okay, I know that the area is between negative 1, here's negative 1, and 2. I shade in the area. And now, can anyone tell us how to write the integral that will give us the area enclosed between x plus 2 and x squared. Anybody, please?
So would the integral be, would it be 2 to negative 1 from those points that we got?
We read from left to right.
So from negative 1 to 2.
Excellent. Perfect. From so we have the area, the integral from negative 1 to 2. Perfect. From
X squared minus x minus 2.
above minus below.
Oh, minus.
Above minus below dx. So the integral from negative 1 to 2. Above. Which function is above?
Is x plus 2 above?
Very good. Minus which function? I know it's silly, but I just want to hear you say it. Minus the function from below. Which one is below?
X squared.
Very good. Good. That's all we need to do. So this is x squared over 2 plus 2x minus x to the third over 3 from negative 1 to 2. We always plug in the upper limit first. So 4 divided by 2 is 2, plus 2 times 2 is 4, minus 8/3, minus, and now we plug in negative 1. 1/2 minus 2 plus 1/3. This is not a big deal. So we have 6 minus 8/3 minus 1/2 plus 2 and minus 1/3. So this is 6 plus 2, which is 8. Negative 8/3 minus 1/3 is negative 9/3, which is minus 3. And then minus 1/2. So this is 5 minus 1/2, which is 9/2. But you see, we had way more work to do because number one, the graphs were not given to us. The points of intersection were not given to us. We also had to find the area. We had to shade in the area. And then we had to establish the integral, and the integral is always above minus below. Okay, let me explain why it's above minus below, because maybe it's not clear, and once it's clear, you will not forget. Okay, so we have a function that is g of x. We have another function that is f of x. And we have the points of intersection from A to B, and this is the area. So here's the reason why it's above minus below. Above the area between, or I should say, under the graph of f of x, minus below, minus the area under the graph of g of x. So above minus below gives us this area. Above area minus below area gives us the area that we are interested in. So we determine the area under f of x, and we subtract the area under g of x to get this area. Is that better? Does it clarify it now? Perfect. That is the reason why it's always above minus below. And the answer will never be negative. Ever, 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 ever. Even if this area is right here. It doesn't matter. So let's go back to our graphs for a second. When we looked at the graphs, we said that I think it was, let me see. Yes, 413, 414, yes. I just want to make sure you understand 414. See, here, all this area, because it's under the graph, under the x-axis, all this area will be negative. Because it's between the x-axis and the graph. But here, this is an area enclosed between two graphs and none of them is the x-axis. Even if they happen here, it doesn't matter. Even this will be a positive area. It does not involve the x-axis. Good. Any questions on, let's go back to which page was that? 425. Any questions on the steps that we followed to determine the area enclosed between y equals x plus 2 and y equals x squared? Is this clear? Okay, everything else will be slightly more difficult. So let's choose something else. What I would like to, would you like to choose another problem or not? I'd like to choose one more. Is that okay? Is that a yes? I cannot see you once I share my screen. I cannot see you.
Yep.
We want to look at another problem. Okay, very good. So let's try this 21. Also a simple situation. In 21 we have y equals x squared and y equals the square root of x. Two very simple functions again. We know how to graph x squared. No problem at all. It's a very, very simple function, very friendly function, symmetric. So y equals x squared. Now, I know how to graph the square root of x. When we graphed the square root of x when we listed those simple functions. The square root of x is something like this. Obviously, this is the area in question. But we need to determine the points of intersection. We cannot proceed. So y and y, so x squared equals the square root of x. Well, I don't know if you remember when we solved radical equations, we have to square both sides. So I have x to the fourth equals x. We move x to the other side, x to the fourth minus x equals 0. Because we have to set it equal to 0. It's a polynomial equation. We have to factor out the greatest common factor, which is, can anyone tell us what is the greatest common factor here that I have to pull out?
X.
Of course, thank you very much. And then we have x cubed minus 1. Now, this has only one solution. So we have two options, x equals 0, and the other option is x cubed minus 1 equals 0. So this x cubed equals 1 has three solutions, but two are imaginary. And the only solution that is real is x equals 1. As expected. So they do meet at 0, and they do meet at 1. So we have the points of intersection when x is 0 and when x is 1. We have graphed the two functions. We found the area. We shaded it in. Now we need to write an integral to find the area. So the area equals the integral. What do we need to write? Anybody?
The integral from 0 to 1, and you would do the square root of x minus x squared.
Excellent. The square root of above minus below. Perfect. Okay. In order to integrate this, remember we have to replace it by x to 1/2. So then we have x to 1/2 plus 1, which is 3/2, divided by 3/2, minus x to the third over 3 from 0 to 1. Luckily, I only need to plug in 1. Flip. So this is 2/3 minus 1/3. Lucky me, 1/3. Any questions? Anybody, any questions?